All right, we're going to take a look at working with similarity. Now, we had taken a look at this a little bit earlier when it comes to the similar figures like we had looked at in 41. Now, are these shapes the same size for everybody in this room? Why? Well, it doesn't matter whether 8 goes into 20 or not. I said, are these figures the same for everybody in the room? Or are they the same? Well, fine. Are they the same size for everybody in the room? Why? Well, is the one that's smaller smaller for everybody? Is the one that's bigger bigger for everybody? But are they exactly the same size for everybody? Okay. So, well, you've done this before when you've been completely bored and somebody just keeps droning on and you look at them like this and go, right? Now, I got a question for you. When I was doing this, poor Hannah, when I was squish, 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 if Hannah would be sitting here, would her head be the same size from here? No, of course I wouldn't do such a thing, but with that thought in mind, are those shapes the same size for everybody in this room? Why? Absolutely correct. Because everybody is a different distance away from what about what? Are they the same distance away? What, because they're sitting in the second desk in each row? Is one row further away from the board than the other? Okay, but even if you don't measure it, does it make sense that one row is further away than the other? Okay, because they're obviously not in the same place, right? Otherwise, they'd be sitting on top of each other, and that would be mildly uncomfortable, right? Mildly. So everybody's at a different place in the room. Everybody's at a different distance in the room. So everybody's going to have a slightly different size image of what you see on the board, correct? Does that make sense? A little bit more sense to you, Aaliyah? I mean, if you got up and walked really, 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 really close to that board, your nose was almost touching it, would they look a lot bigger than if you walked all the way to the back of the room? Yeah. So when you're looking at these things, there's a certain level of perspective that you have to keep in mind. But are these shapes going to be the same to each other for everybody in the room? Is that ratio going to be the same? Is that comparison going to be the same for everybody? In other words, because one side here is 20 and this side is 8, is that ratio, is that comparison always going to be the same? Okay. So how much bigger is 20 than 8? 12? So you're saying that I should add 12 to everything in order to get to it, right? It doesn't quite work that way, does it? By 2.5. Okay. So you went and took 20, divided it by 8, right? And that went down to, I can reduce down to 5 over 2, 5 over 2, which would be 2.5. So if I take 8, multiply it by 2.5, that should equal 20, right? According to what I was told. So, let's see here once, get this moved over. Calculator on, so I take 8, multiply it by 2.5, and I end up with 20. Cool. Now, what happens if it isn't that nice and easy to solve? I mean, 8 to 20, it was fairly simple, right? What would happen if I tried to set it up like this? I had my 20, and I have my 8. You've seen me do this before. And say I want to solve for x. Well, because the 8 and 6 go together, I put the 6 over here. The 20 and the x go together, so I put the x over here. Now, again, I hate to use certain terminology because people will always transfer that and do the wrong things in the wrong place. So I can take 6 and 20 and multiply on the diagonal, right? That's what we've seen before, and divide by 8. So if I go and take 6, multiply it by 20, divide it by 8, I end up with what? 15. Is that 2.5 times 6? Would it be? If I go and take 2, multiply it, or correction, 2.5, multiply it by 6, I got 15. So it does work. Would it work the other way around if I wanted to find y? Would I be able to go and say, hey, 20 and 15 go together here, y goes in over here? So does that mean I take 8 times 15 divided by 20? For those of you paying attention, following along, and pretending you're interested. 8 times 15 divide by 20, and I get 6. Does that make sense? Should have that happened? Well, it should have, because if I had 15 here and I have 15 here, that means if I have 6 here, I should have 6 there, right? Those things should always stay the same. So what I want you to do, I'm going to give you a few moments here, and I want you to go through and do this practice problem. So, Aaliyah, what value did you get for x? Okay. What did you get for y? 9. Okay, so let's check this out and see how this goes. Now, I'm going to show you a good way of writing this out so it makes your life a little bit easier. So we've got triangle JKL is supposed to be similar to triangle FGH. Now I see that I have common numbers between here, or a number in common between there, so that means I've got 11 and I've got 33. If I want to go through and find x, well, x goes with the 11, and what goes on the same side as x? 21, correct? By the way, do I always have to make sure that I have things lined up? You know, J goes to F, K goes to G, L goes to H. It's always a good idea to double check that. So if I've got that, that means I am going to take 11 times 21, divide by 33, and I end up with 7. Absolutely correct. So if I try the other one, where we have 27 over here and I have y over here, that means it would be 11 multiplied by 27 divided by 33, and I end up with 9. Absolutely correct. So think about this. This idea of the similarity goes through for anything, okay, when we have similar figures. Doesn't matter whether they're rectangles, triangles, or in this case, pentagons. Now, we should really do the same setup that we had before. We've got A, B, C, D, E is supposed to be similar to F, G, H, I, and J. What is the ratio similitude to this thing? Well, it says 3 to 2. That's nice. Do we have any numbers on the ABCD or any sides on ABCD that correspond to something on the other one? 12 corresponds to what? Okay, so if I got a 12 here, this is supposed to go to x squared plus 4, correct? Oh, that's no number. That's ugly. I don't have a side here that says anything about how to compare these two, do I? Do I have any information that compares these two together? Is there anything there? What about in the 3y minus 6, but there's nothing corresponding over here. Okay. Good try. Is there any other information that we are given? The ratio 3 to 2. So which one is 3? Well, if A, B, C, D, E is first, that should be the 3. So that means this one's 3, and this one here has to be 2. So do I have numbers that are comparing the first to the second? I have some. So that's got to be 3. That's got to be 2. Okay. So now I'm going to set this up because I got numbers and stuff going on here. So if I do what I did before, it means I should take 2 times 12 and divide it by 3, and that'll give me this number up here, correct? Isn't that what it's supposed to do? So what's 2 times 12? What's 24 divided by 3? 8. So this has to be 8. So notice how I didn't even bother messing with this x squared plus 4 bit and multiply it through. All I know is that x squared plus 4 must be equal to what? 8. Because I had the 2, the 12, and the 3, it's got to be 8. So now I can go through. X squared is equal to 4, so x is equal to what? What's x equal to? 2. Good. That's easy enough, right? By the way, what's the value of y got to be? Well, what does 3y minus 6 need to be equal to? Well, I got this side here. There's nothing over here, is there? What kind of polygons are these? Regular. So that means if that's 12, what's this side here? What's this side here? What's this side here? What's this side here? So 3y minus 6 is equal to 12, correct? So what's y equal to? Well, remember, it's got to be 3y minus 6 is equal to 12. Add 6, add 6. 3x is equal to 18, so x is equal to what? Or y, yeah, my bad. So y is equal to what? 6. By the way, how long is FG? 8. So if that's 8, that's 8, that's 8, that's 8, and that's 8, right? Just for the sake of argument. Now they want to know what the ratio of the perimeter of ABCD is to FGHIJ. What is the perimeter of ABCDE? 60, I hear. Okay, so we got 60. What is the perimeter of FGHIJ? 40, because there's 5 sides times 8 is 40. Can I simplify this down? And the answer is yes. So I could look at this as, hey, this could be 6 to 4. Could I simplify this even further? 3 to 2. Same thing as what it is up here. Because we are just talking distances, the ratio will stay the same. So I'm going to give you a few minutes here, and I want you to go through and do this problem. So this is how I would approach it. I got triangle ABC. So triangle ABC. AB, well, that would be x squared minus 7. BC would be y plus 4. And CA would be 5. Another triangle, we got D, E, and F. Now it says DE is 6, EF is 12, and FD is 15. Now, is there a quick and easy way that I can deal with this? Okay, so you're saying here that these two go together, right? And it's a 3 deal, right? So if I know that this is 15, 15 to get to 5, I got to divide by 3, correct? So would I know exactly what I'd have to have over here? What would it be? 4. So this side here should be 4. So that means that y plus 4 has to be equal to 4. So what's y equal to? 0. What's this got to be over here then? 2. So that means that x squared minus 7 is equal to 2. Add 7 to both sides. X squared is equal to 9. So x is equal to what? 3. Always draw it out. And then you can see a lot easier where you may have a shortcut at. This is a shortcut. You don't always get numbers that work out like this, but when you get numbers that work out like this, that's real quick and easy. Do it. So, I'm going to give you a few moments. Make sure that you write that down. All right, here we go. Now, I want to prove the relationship between the perimeters of similar figures. Now, we're going to go through this, try and create ourselves a nice logical argument for this. So, first offhand, we are told that triangle PQR is similar to triangle STU. Well, that was given. We know that the ratio of PQR, which is 1, to STU, which is 2, was also given, okay, for their corresponding sides. So, if I use this idea of the corresponding sides, would one of the PQ be equal to 2 of the ST? Should that be true? Okay. Now, mind you, that's our corresponding sides that we've got up here. Would one of the QR be equal to 2 of the TU? Should that be the case? Again, that's by corresponding sides. Would one of the RP be equal to 2 of the US? Is this true? If we've got our relationship of 1 to 2. That seemed to make sense? So, would that also mean that I would have one of the PQ plus 1 of the QR plus 1 of the RP? Would that be equal to 2 of the ST? Sure, write things the way I want them to. Of the ST plus 2 of the TU plus 2 of the US, and then say that this is the definition of perimeter? Is that true? So if I add all 3 of these up here and add all 3 of these up here, that should be the same, correct? Now I'm going to change this for a second. So if I've got 1 in PQ plus QR plus RP, is that equal to 2 times ST plus TU plus US? Is that true? Is that still, I just factored it out, didn't I? Factored a 1 out of each one of these, factored a 2 out of each of those. Is that correct? So then, could I say that if I had 1 of, by the way, what do I call that when I add all the sides up? So what is it called when I take this side plus that side plus that side? That's the perimeter, right? So if I say that I have the perimeter of PQR is equal to 2 times the perimeter of STU, again, that's the definition of perimeter. Did I just prove what I was supposed to? Because I got the ratio of the perimeters is 1 to 2. Is that what I've got down here? 1 to 2? Okay. Again, all a proof is just a logical argument that you go through to make a conclusion. So, let's try this. Say I want to solve this problem here. It says figures HIJK, LMNO are similar polygons. Their corresponding sides have a ratio of 2 to 5. If the perimeter of the figure HIJK is 27, what is the perimeter? Now, I could draw this out, but I don't have any sides to go together and put to each other, do I? So that could be helpful, but not necessarily. But this is how I'm going to write it. So I'm going to have HIJK is similar to LMNO. Okay. Do we have a ratio for that similarity? And that's 2 to 5. Now the first one goes with the first one. So this is going to be 2. This is going to be 5. Now, we are also given something in HIJK. It's supposed to be 27 inches. So 27 is supposed to be over here. Question is, what would go over here? What would be its corresponding length? Now, 2 to 5 isn't bad, but it's kind of ugly, isn't it? I would rather set it up like this. Because if I do that, then I know exactly what I got to do. 5 times 27 divided by 2. So that means that I would take 527 divided by 2, and I end up with 67.5. By the way, how much bigger is 5 than 2? Isn't it 2.5? So if I take 2 times 2.5, I end up with 5, so 27 times 2.5. Why did I say 2.5? 2 times 3 is 5? Yeah. When we're dealing with this, it's always going to be a multiplicational factor. Yes, 3 is bigger than 5, or I should say, good. 5 is bigger than 2 by 3. So if I was going and using the rule of adding 3 and adding 3 here, that would give me 30, correct? Now, whenever we have these ratios, this ratio here has to be the same as this. So what's 2 divided by 27? Well, 2 divided by 27 turns out to be that weird looking number. Okay. If I go and take 5 divided by 30, I don't get that weird looking number, do I? But if I were to go and take 5 divided by 67.5, I get that weird looking number again, don't I? These are always going to be in the form of a fraction, and the fractions are always going to be equivalent fractions. You know, so like 1/2 is the same as 2/4, right? Which is the same as 3/6, 4/8, 5/10. Kind of see what I'm saying there? Yes? No? Maybe? Hello? Bueller? So it always has to have that ratio. And the thing is, if you ever want to check to make sure that you've got it right, just take the fraction and divide it and see what you come up with. So I'm going to give you a couple of minutes, and I want you to do this problem here. Jacob, what is the perimeter that you had for A, B, C, D? We don't like guessing. So if I didn't know how to approach this, did you write down this? A, B, C, D is similar to E, F, G, H. Did you write that down to begin with? Okay. This is step one. So we know what is being similar to the next. Okay. Do I have any information about a side on A, B, C, D and a side on E, F, G, H? Okay, so you got a 45. But that's a perimeter, that's not a side, is it? Okay. Do I have any information relating what A, B, C, D is to E, F, G, H? Okay, so this is 3. This over here is 5. So now that we are told the perimeter down here is 45. We are looking for the perimeter that goes over here, correct? See, by writing this out, it helps you set up your ratios. Okay? Because if you can get to this, do you know how to go and figure this out? You take 3 times 45, correct? And then divide by 5. And what do you get? 27. Okay, there we go. 27. Because this here, this 45 here was identified as the perimeter. Okay, so that means the perimeter has to be the same over there. And by the way, would 3 over 27 reduce down to the same thing 5 over 45 would be? Because this would go to 1 over 9. This would go to 1 over 9. Okay. So it doesn't matter whether you simplify them down to fractions or if you go and divide them out to a decimal and they're the same. They have to be equal. That's why we put this equality sign in here. That one side is equal to the other. So, give you a few moments, give this one a whirl. So, Logan, what did you get for the perimeter of FGHIJ? 144. Let's give that a check. So if I've got A, B, C, D, E is supposed to be similar to F, G, H, I, and J. I see that we have a ratio similar to 2 to 9. We are told that the perimeter of ABCD is 32. So we're looking for the one that's over there. So let's see, clear that out. So it'll be 9 times 32, enter, divide by 2, and I end up with 144. Absolutely correct. Excellent. Now, applications of this stuff. You guys ever read a map? No. You've never read a map in your life? Maybe once, just once, right? Okay. GPS? Sure, Google Maps counts, yeah. The problem is if you're actually using Google Maps, sometimes they give you the scale. They tell you how much is on the image that you get compared to how many miles in reality that is. So if it says Fox plans to jog 5,000 meters a day in training for a race, the park where Fox jogs is in the shape of a regular pentagon. The side length of the park is 5 centimeters long on a map with a scale of 1 centimeters to 50 meters. How many times does Fox need to jog along the perimeter of the park to complete his daily routine? Okay, so here we go. He's got two things. He's looking at the map and he's looking at the park. Okay, so side length of the park is 5 centimeters, right? Now, we want to know what the park is going to be. So if I was just going by the numbers, do I have a scale that goes and tells me what's on the map to what's on the park? Okay. Now it doesn't necessarily say which one the map goes to, does it? Does the map go to the top or the bottom? Numerator, denominator. So we got to do a little investigating here for a second. The length of the park is 5 centimeters on a map. So would the 1 centimeter go here? Yes or no? Would the 50 meters go here? By the way, what label would I have to have in the park now? Meters. Good. Because the map is centimeters to centimeters, this has to be meters to meters, correct? These have to match, those have to match. Doesn't matter if you're going from centimeters to meters or meters to centimeters. So I set this up, and basically that means that it's going to be 50 multiplied by 5 divided by 1, 250. So the park would be 250 meters. Well, that kind of makes sense, right? Because if the park is, each side is 50, and there's 5 of them, 250 meters. So how many times does he have to go around if he needs to run 5,000 meters? Well, would I take 5 and divide by 250? So that means he has to make 20 laps. Doesn't that sound like fun? So, I'm going to give you a few moments and give this one a try. All right, here I go. Let's see if I can figure this out. So they're designing a door for the treehouse with two separate doors, one that is proportional to her height and one that is proportional to his height. Okay, so Jacob is 3 feet tall and Jana is 4 feet tall. So we've got Jacob is 3, Jana is 4. So Jana decides that her door should be 5 feet tall by 2 feet wide. Okay. How tall should Jacob's door be, and what will its perimeter be? Now, could I use the information right here to create a ratio for tall? Okay. So 3 times 5 divided by 4, so that would be 3 times 5 divided by 4, and I end up with 3.75 feet. Okay, does that work? Could I then use this ratio here in the information down here to figure out how wide it should be? Okay, so that means that I got 3 times 2 divided by 4, and I end up with 1.5. Okay, so what will its perimeter be? Well, if I'm going around the door, wouldn't that be 1.5 plus 3.75 times 2? 10.5? So there you go.